Today we're going to focus on solving trig equations. And the best way to do this is to jump right into examples. So let's say we want to solve this one. 2 times the cosine of x minus 1 equals 0, with the stipulation that x is greater than or equal to 0 and less than 360. So what we're trying to do is figure out what x equals. Well, obviously we want to isolate the cosine of x, so we're going to add 1 to the other side and then divide by 2. And we're going to be left with the cosine of x is equal to 1/2. Now there's no need to use the inverse cosine to get x by itself. We can just think when from 0 to 360 is the cosine equal to 1/2. And if it helps, we could use our friend the unit circle. Put it over here somewhere. Okay, that looks good. And say, where is it equal to 1/2? So let me draw an arrow. We can refer to this. And we know the cosine is equal to 1/2 up here at 60 degrees. That's when the x-coordinate is 1/2. Not over here, though, in the second or third quadrant, because the x value is negative. And then down here in the fourth quadrant at 300 degrees. So 60 degrees and 300 degrees are my two answers. And that's it. Now we don't want to write this in radians because the stipulation was that x is between 0 and 360. So we want to keep the units in the units that were specified in the problem. So there we go, 300 degrees. Now that seems easy enough. Now what I want you to understand though is if they didn't give us that stipulation that x was between 0 and 360 and we graph the cosine graph, well, we know that the cosine is going to equal 1/2 at a lot of different places. If I hit trace and type in 60, whoops, I'm sorry, I'm in radian mode, so I'll type in pi over 3. And there you can see y is equal to 1/2 or 0.5. And then we could also do 5 pi over 3. So let's type that. And we have 1/2 again. If I graph y equal 1/2, you can see that it's going to hit the cosine graph in an infinite number of places. More about that later. All right, let's look at another example. Let's solve this one. And by the way, it's a good idea probably to hit pause, try and solve it, and then come back and see how you did. So we want to solve this. So let's get the sine by itself. So we're going to have sine squared of theta is equal to 3/4. And then we're going to take the square root of both sides. And the square root of sine squared is the absolute value of sine. And the square root of 3/4 we can simplify to the square root of 3 over 2. So that tells me that the sine of theta is going to be equal to plus or minus the square root of 3 over 2. Now the stipulation here was that theta is between 0 and 2 pi. So we're going to give our answer in radians. And once again, you can go back to the unit circle and think, where is the sine equal to root 3 over 2? Lost my arrow. We'll make another one here. So sine is equal to root 3 over 2 up here, pi over 3, or 60 degrees. That's the y-coordinate. Over here at 120, or 2 pi over 3. And then jump down to here. It's negative root 3 over 2 at 4 pi over 3. And then across here, negative root 3 over 2 at 5 pi over 3. So those are our 4 spots, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And so those are our answers for theta. And once again, we could check these on our calculator just to verify those results. All right, let's take a look at another type of equation. This one says, find all the solutions. Notice there's no stipulation here on, the variable here is y. There's no stipulation on y being between 0 and 360 or 0 and 2 pi. So what are we going to do here? Well, if I add the sine of y to both sides, I'm going to have 2 sine y on the left. And then I'll subtract that root 2 over to the other side. And then I'll divide by the 2. So I have sine of y is equal to negative root 2 over 2. Now, once again, if you go back to the unit circle and take a look at that, when is the sine equal to negative root 2 over 2? The sine is negative down here in the third and fourth quadrant at those 45-degree reference angles. So at 225 degrees and 315 degrees. But notice, if I go around here once to 225 degrees, the sine is negative root 2 over 2. But if I add another 360 to that, so that's at 585 degrees, it's also negative root 2 over 2, and so on and so on. So every time I add another multiple of 360, I'm getting right back to that same spot, and the sine is equal to negative root 2 over 2. Likewise, that's true for 315 degrees. So if I add 360 to that, 675, and another 360, and another 360. Also, if you think of going in the negative direction, negative 45 degrees, negative 135 degrees. So what we're going to do is we're going to find those spots on the unit circle that correspond to the sine equal negative root 2 over 2, and then we have to add multiples of 360 to those. So here's how I'm going to write this. Y is equal to, the first answer was 225 degrees, plus any multiple of 360. So 360n, where n is an integer. So if n is a negative 1, that would give us negative 135, etc., etc. And then it's also equal to 315 degrees plus any multiple of 360. And so there's an infinite number of answers, but all the answers are covered by those two expressions. And this didn't specify degrees or radians, so if you would rather do it in radians, you could say 5 pi over 4 plus 2 pi n, and then 7 pi over 4 plus 2 pi n. And so either one of those would be acceptable. Now let's take a look at another one. And we might want to borrow the unit circle here for this. My arrow, put that down there. All right, let's solve this one. We've got cosine squared equal 2 cosine x. There's no stipulation that x has to be in radians or degrees or within a certain range. So, how do we solve this? One of the big mistakes you can make is, hey, let's divide both sides by cosine of x. You don't want to divide by the variable because you're throwing out potential solutions here. So what you always want to do is get everything over to one side and then factor out. So I'm going to have cosine squared of x minus 2 cosine of x equals 0. And now I can use the zero product property. I can factor out a cosine, and then times a cosine minus 2. So I have two possibilities. The cosine of x is equal to 0, which I would have lost that potential solution had I divided both sides by cosine to start with. And then I also have cosine of x minus 2 equals 0, which means cosine of x equals 2. Well, right away you should stop and think for a moment, and the cosine of x could never equal 2. The cosine takes on values between negative 1 and positive 1. So there's no solution for that. So now we just need to look at when does the cosine equal 0. And the cosine is equal to 0 at pi over 2 and at 3 pi over 2. Or if you want to do it in degrees, 90 and 270. So at pi over 2 and any multiple of 2 pi will get you back to that same spot. Or 3 pi over 2 plus any multiple of 2 pi. But now you might notice that these two answers are exactly half a circle away. So I can condense my answer down and just say pi over 2 plus any multiple of pi. So plus 1 pi, plus 2 pi, plus 3 pi, etc. So let me write out the longer answer and then the simplified version of it. So here we would say x is equal to pi over 2 plus any multiple of 2 pi, or 3 pi over 2 plus any multiple of 2 pi. But we can condense that down and just make it pi over 2 plus pi n. And so that would be our best simplified answer for that one. Let's go to, and once again, you can graph this and check that out on the calculator as well. Okay, let's look at this one. Finally, we're dealing with something besides sine and cosine. How about 3 tangent squared minus 1 is equal to 0? So the idea is to isolate the trig function. So I'm going to have tangent squared of theta is equal to 1 over 3. And then I'll take the square root of both sides. And I get the absolute value of tangent is equal to the square root, or 1 over the square root of 3. And so we'll put the plus minus right over there instead of writing out the absolute value. So when is the tangent equal to 1 over root 3? Now if you've done enough work on the unit circle, you're going to recognize that. But if it helps, a more complicated version of this answer is if you think of it this way. And that means what we're looking for is when is the sine equal to 1/2, plus or minus 1/2, and the cosine is plus or minus root 3 over 2. So that happens at several spots here on our unit circle. So the sine is a half, positive 1/2 right here, and the cosine is root 3 over 2, so it happens here. It also happens across here. The tangent would be negative 1 over root 3. And also down here, the tangent would be positive 1 over root 3. And then across here, we get the tangent is equal to negative 1 over root 3. So we have these 4 spots. Notice the symmetry on our unit circle for those 4 answers. And this didn't specify where to put the answers. So we could list each one individually and say plus 2 pi n. But if you notice, 150 and 330 are directly across from each other. I'm going to do my answer in radians. So 5 pi over 6 and 11 pi over 6, those are exactly half a circle apart. So I can go with the first answer, 5 pi over 6, and say plus pi n. And that'll include the 11 pi over 6, and then back here if I add another 2 pi to that one, and another 2 pi to that one, etc. So let's take care of those two first. So 5 pi over 6 for theta plus pi n. And then the second one happens down here at 7 pi over 6. And notice that's also straight across from pi over 6. So I'm going to go with the pi over 6 plus pi n, which will take me to these 2 points over and over again, as many times as I go around the circle, either clockwise or counterclockwise. So pi over 6 plus pi n. Maybe I should have switched the order, doesn't really matter. Now if you're doing this in degrees, you could say 30 degrees plus 180 n, and then the other one would be 150 degrees plus 180 n, whichever you prefer. Okay, let's look at one last example. Let's solve this one. And this takes a little more work on the front end. All right, notice the difference here is I have a sine and a cosine. But if I step back a little bit and look at this, it kind of looks like I have a quadratic here. And with quadratics, we can factor. So it would help if I had the same function, though. Well, one of the most often used Pythagorean triples is the sine squared equals 1 minus the cosine squared. So I'm going to replace the sine squared with 1 minus cosine squared. And then I'm going to distribute that to combine like terms and see where I'm at. So I'm going to get a negative 2 cosine squared plus 3 cosine x. And then we'll have a 2 minus the 3 is minus 1 equals 0. And I don't like the negatives when I'm trying to factor with my squared term. So I'm going to multiply both sides by negative 1. And this is going to become a minus 3 cosine and a plus 1. All right, so let's see if we can factor this. Now if we couldn't factor, we'd have to do the quadratic formula. and that takes a lot more work. So 2 cosine squared is going to be 2 cosine times cosine. And for the 1, it has to be a 1 times a 1. And since my middle term is negative, both of these will be negative. So if you go ahead and distribute, or FOIL, that's going to give me a 2 cosine squared. That'll give me a negative 2 cosine x. Another negative 1 cosine x combines to be negative 3 cosine x. And then a positive 1, or plus 1. So I factored it correctly. I checked that by distributing. Now I have something times something equals 0. That means that 2 cosine x minus 1 equals 0, or cosine of x minus 1 equals 0. Which means that the cosine of x is equal to 1/2, or the cosine of x is equal to 1. Now notice we did have a stipulation here. X is going to be between 0 and 2 pi. So with that restriction, I'm only looking at the unit circle from 0 to 2 pi. So let's pull that back down here. Put another arrow on this. And when is the cosine equal to 1/2? Well, that happens up here at 60 degrees. We're in radians, so pi over 3, and down here at 5 pi over 3. So the cosine is the x-coordinate is 1/2 there, pi over 3 and 5 pi over 3. So those are the two possibilities there. And then the other possibility is we have the cosine is equal to 1, and the cosine is only equal to 1 here. Now is that 0 or is it 2 pi? Well, looking back at our restrictions, x can be greater than or equal to 0, but not equal to 2 pi. And that's why this inequality, one will be including an endpoint and the other won't, because they're really the same spot on the unit circle. So we're going to go with 0 for here. And so those are our 3 solutions to that equation. All right, the assignment is 5.3, starts on page 373.